Welcome back to math. I sighed because this is not my first time to make this video. Last video was 5 minutes 2 seconds, just 2 seconds more than required, so it won't let me send. So let's make this video within 5 minutes this time. Alright, welcome back to school after 1 week break, and welcome to math class. It's very enjoyable, I know. This lesson is about parallelogram, rhombus, and trapezoid. Parallelogram has nothing to do with lollipop, even though it does have 2 L sounds. That's what it reminds me every time I say it. ABCD is a parallelogram. By definition, it means AB is parallel to CD. This is how we can write it. AB parallel to CD with a line segment symbol on top of it. Parallel means these two lines will never meet forever. The distance between these two lines are always the same. They go in the same direction, exactly the same direction. All right. In the same way, AD is parallel to BC. All right, the opposite two lines. And now let's explore the properties of the angles. In the textbook, you cut out shapes and you put them together so that you know angles are the same, lines are the same, and I don't think that's very mathematical. So we're going to be exploring the properties of the angles in a smarter way, more mathematical way. Everybody knows that Chinese are better at math. We're smarter at math. Anyway, so let's look at angle B and angle C. That's right here. Angle B, and should I write it in black? Angle B and angle C. What is the relation between them? Are they equal, or are they add up to a certain degrees? All right, don't forget the M. Let's explore. Let's extend BC a little bit more so that now we can see another angle. Let's call it E. Since AB and CD goes in the same direction, exactly the same direction, what do you say about angle B and angle E? M angle E. Wait. Angle B and angle E has to be the same, right? Because these two lines go to the same direction and on the same line, they have to be the same. If CD goes this way, then angle E will be bigger and CD will not be parallel to AB. And it cannot go this way either. It has to be exactly the same direction. It has to be exactly the same. So angle B and angle E are equal. What do we know about angle C? Measure of angle C plus measure of angle E. I just can't talk and write at the same time. Angle C and angle E are angles on a line, so they add up to 180 degrees. So what do we say about angle B and angle C? Angle B is the same as angle E, so angle C plus angle B is 180 degrees. Let me pause it now. All right, what we said is angle B plus measure of angle C equals 180 degrees because angle B is equal to angle E. In the same way, we can prove that. All right, let's be clear. Angle B and angle C are angles in between the parallel lines. All right. So angles in between the parallel lines add up to 180 degrees. These two angles. Does it apply to these two angles? AD and BC are also parallel. Well, it does seem like so. But I'm going to extend it this way though. Alright, now let's call this little cute angle, well, it's not a cute angle, it's an obtuse angle, F. Angle C and angle F are equal since these two lines go the same way, right? And angle D and angle F are angles on a line, so angle C and angle D make 180 degrees also. Measure of angle C, measure of angle D is 180 degrees. I hope it's still making sense to you. Please don't fall asleep. Alright, now we have found out angle C plus angle D is 180 degrees. In the same way, we are going to find out that angle A and angle D, they also make 180 degrees because angle D is the same as angle G. A and G are angles on the line, and angle D and angle A also make 180 degrees. A plus M of angle D is 180 degrees. The same thing for angle A and angle B. If you extend the line to either way, well, let's do it. This is H. Angle A and angle H are the same. Angle H plus angle B is 180 degrees. So angle A and angle B is 180 degrees. M of angle A, angle B. All right. Now we know about the properties, some of the properties of the angles of a parallelogram. Each pair of angles in between the parallel lines, they add up to 180 degrees. So it's these two, these two, these two, and these two. And we also can say that angle B is the same as angle D. It's the same. Angle B is the same as angle D. Right. Angle B and angle D the same. Angle Okay, I just straightened my thought. So we know that angle B and angle D are equal because see, angle C the same, B and D. Angle B equals angle D. So B and D are here. So the opposite two angles are equal. Same as angle A and C. Look, angle C plus angle D is 180. Angle A plus angle D is 180. So angle A and angle C has to be the same. Angle A plus angle C. Angle A and angle C. So we can say that the opposite two angles in a parallelogram are equal angles. The angles next to each other, which is angles in between the parallel lines, add up to 180 degrees. Is that clear to you? So you can draw, let me draw here. I'm going to draw it very quickly. You can draw any kind of parallelogram as long as these lines are parallel. Let's name it 1, 2, 3, 4. And measure of angle 1 is equals to measure of angle 3. Well, in Chinese, we use a lot of numbers for angles. Measure of angle 2 equals measure of angle 4. Measure of angle 1 plus measure of angle 2 is 180 degrees. Same as these two angles next to each other, these two angles next to each other, and these two angles next to each other. All right. And even in rhombus, do you remember what a rhombus is? A rhombus is technically a parallelogram, except that it has 4 equal sides. I don't know if I can quickly draw a parallelogram without a good ruler. I don't know. Okay, it doesn't look too bad. So a rhombus is a parallelogram with 4 equal sides. Wait, I forgot about one thing about, well, before we move on the sides, guys, we have found out the property of the opposite parallel lines, all the angles, and there's one more thing which is important. Sorry, I forgot. These two lines that are parallel, they are also equal to each other, because we can easily prove that if we draw perpendicular lines, we can say that this angle is the same as this angle. This is 90 degrees, this is 90 degrees. So this angle is the same as this angle, right? And because these two lines are parallel, so the distance between the two lines are the same. So these two triangles are actually the same, we call it identical triangles. So if these two triangles are identical triangles, they're this line opposite to the right angle, these two lines are equal. They have equal lengths. All right. So let's put here AB equals to CD. In the same way, BC equals to AD. So the opposite two lines are parallel to each other and they have equal lengths.